So let's read through this question here. Okay. It says 32 teams are participating in a basketball tournament. Only the winning teams in each round advance to the next round, as shown in the table below. So the first thing is just kind of really trying to understand what's happening here. Okay. And let's look at the table here, right? At the top, number of rounds. So 0 rounds, 1 round, 2 round. This is telling me how many rounds have happened. And down here, how many teams are remaining. Okay, so I start with 32 teams, I'm down to 16 teams, 8, and so on. The question itself is asking which function type best models the relationship between the number of rounds completed and the number of teams remaining. Okay, so now remember in Algebra 1, these down here are really the four main types of relationships that we study. And the easiest way to really differentiate these relationships is by focusing on their rate of change. Okay. Now, the first thing I like to do up top is look at the x values and check how are the x values changing. Okay, is that's pretty standard. These x values here are all increasing by 1. Okay, so because they're increasing by 1, that just simplifies things a little bit. Now I'm going to look at the y values, and my first check is always, is it linear? Okay, now it's going to be linear if it has a constant rate of change. Okay, so how do I check for that? Is just how do I change from 32 to 16? Okay, that's not too difficult. Okay, I'm subtracting 16. Now, what happens next? From 16 down to 8, wait a second, that's actually minus 8. So that actually gives me some important information as I know it's not linear. Okay, is that change itself is not constant. It's not the same, which actually would not also be absolute value. So at this point here, really, I know it's between exponential or quadratic because that rate of change is not the same. Okay, now the next thing to check for is it exponential? How do I decide if it's exponential or not? Is I'm looking for a growth factor or a decay factor. Now, in this case here, I know that these numbers are getting smaller. I know that they're decaying. Okay. So from 32 to 16, the question is, what would I multiply by? Or sometimes it's also easier to think about it as division. Okay. Because division and multiplication are intertwined. But to get from 32 to 16, I'm cutting it in half. I'm dividing by 2. From 16 down to 8, again, I'm cutting it in half. From 8 to 4, I'm dividing by 2 again. So every step of the way, I'm dividing by 2. That's an earmark of something that is exponential. Now, a lot of times we like to think about it exponential as multiplying. So instead of thinking about it as dividing by 2, I could also think about it as just simply multiplying by 1/2. Okay, so in this case here, my decay factor would be 1/2. That's what I multiply by each time in order to change the y values. Right. But again, the biggest thing is if you're trying to determine what type of relationship you have, what kind of function it is examine your rate of change. Okay. First, do a quick check to see if it's linear. If it's not linear, check for exponential. If it's not exponential, there's ways we can check to see if it's quadratic.